Assalamualaikum and good day. My name is Nur Aina Syafiqi binti Sajani and my team members is Arasu Anak Lelaki Pembentaran. In this presentation, I will explain the design and simulation of PLC SCADA system for Task 1, four-way traffic light control system.
So now I started with PLC for four-way traffic light control system. So in rung 1 is for north side, and rung 2 is for west side, and rung 3 for south, and lastly the fourth rung is for east side. So for first rung, when the system is activated, the not green light turns on, which means this, and remains active for 10 seconds, controlled by timer. Once timer finished, the green light immediately switch to the north yellow, which means this, north yellow light, which run for 2 seconds via timer. After the yellow phase, the system transitions the north direction to the red light, ensuring it stay red while other direction proceed through their cycles, which means the other direction is rung 2. So now I started with west traffic light control interlocking. The west green light is interlocked to start only after the north yellow lights completes its 2 seconds duration. While north transition to red, west turns green for 10 seconds, followed by a 2 seconds yellow phase. This sequence timing prevents any two direction from having a green light simultaneously, maintaining safety at the four-way intersection. This sequence timing prevents any two direction from having a green light simultaneously, maintaining safety at the four-way interaction. So next, followed by rung 3, south traffic light control. Following the completion of the west cycle, the south green light of the west cycle activates for 10 seconds using timer. It then transits to the south yellow light for 2 seconds, which means this, south yellow, via timer, before switching to red. So now I explain about rung 4, east traffic light control. The final stage of sequence activates the east green light for 10 seconds, and then the east yellow light for 2 seconds. Once the east yellow timer finish, a reset signal is sent to the first rung, allowing the entire process to repeat, starting back at the north green light. So for when green light is activated, the green light run for 10 seconds. So after that, yellow light activate for 2 seconds. So after that, the red light will on. So this red light interlock with green light. So in west side, the green light will on, while in other uh, direction of the traffic light will remain red.
Okay, now this is the SCADA system. When the start push button is pressed, the traffic light system start operating automatically. First, the north traffic light turns green for 10 seconds, allowing traffic to move. After 10 seconds, the north traffic light changes to yellow for 2 seconds as a warning signal. Then the north traffic light turns red automatically. At the same time, the west traffic light turns green and follows the same sequence, which is green for 10 seconds, followed by yellow for 2 seconds, and then red. Next, the south traffic light turns green for 10 seconds, then yellow for 2 seconds, and finally red. After that, the east traffic light turns green for 10 seconds, followed by yellow for 10 seconds, and then red. This sequence continues to operate cyclically and automatically for all 4 directions. The system will keep running until the stop push button is pressed. When the stop push button is pressed, the traffic light system stops immediately and all signals are turned off safely. Next, for task 2, this PLC ladder diagram controls a sorting system consisting of a conveyor, sensor, electropneumatic cylinder, a timer, and counters. Initially, the system is in off condition, where the conveyor motor and all cylinders are de-energized and the counter are reset to 0. Okay, first, the start push button is pressed and the PLC latch the system on and the conveyor motor starts moving. At station 1, the photoelectric sensor detects an object and the PLC stops the conveyor motor. At the same time, a timer is activated and the stamping cylinder operates for 3 seconds. After the timer is finished, the stamping cylinder turns off and the conveyor resumes movement. For station 2, if the object is detected as a metal object, the inductive proximity sensor turns on, the PLC energizes and the metal sorting cylinder pushing the object into the metal container. Each metal object sort increment the metal counter by 1. So if it's count one object count, then will count 1. If the second object is detected, it's count 2. And when the third object is count, then it will count 3. Next, for station 3, if the object is detected as non-metal object, the capacity proximity sensor turns on. The PLC energizes the non-metal sorting cylinder, pushing the object into the non-metal container. Also, each non-metal object sorted increments the non-metal counter by 1. Then the plastic object detects, it will count 2. Then the plastic object detects and it will count 3. This sequence repeats continuously for each object. Then, when stop push button is pressed, the PLC unlatch the system, stop the conveyor and de-energize all the cylinder and resets the counter to 0, returning the system to its initial state. Okay, now, this is a PLC SCADA-based sorting system. First, when the start push button is pressed from the SCADA interface, the conveyor motor starts moving. The conveyor will blink yellow, so it's mean the conveyor start moving. Then for station 1, the photoelectric sensor detects an object which is manually simulated in SCADA. When the object is detected, the conveyor stops and the stamping cylinder is activated for 3 seconds using a PLC timer. After the stamping, the conveyor resumes operation. By the way, while the stamping is operated, the conveyor will stop. Then, for station 2, if the object is metal, the inductive proximity sensor is activated and the electropneumatic cylinder pushes the object into the metal container. Each metal object is counted by the PLC counter. Sensor detects a metal object. The counter will count 1. Next, when the inductive sensor detects again the second metal object, the counter will count 2, and the rest will count as 3, 4, and so next, at station 3, if the object is non-metal, the capacitive proximity sensor is activated and the electropneumatic cylinder pushes the object into the non-metal container. Each non-metal object is also counted by the PLC counter. When the sensor detects one plastic object, the counter will count 1. Then next, the capacitive detects for third object, the counter will count 3. Then the process repeat continuously until the stop push button is pressed. Lastly, when the stop push button is pressed, the system will stop and the counters are reset to 0.
So now I continue with task 3. So I design and demonstrate a PLC SCADA program simulation for the liquid level control system. So this is the PLC for the liquid level control system. And this is the SCADA system. So here we can see start PB, stop BB, and manual switch for the output valve, and higher limit switch 1 and lower limit switch 1 for the storage tank, and higher limit switch 2 for the feeder tank. So now let's begin with the start PB. So when I start BB, the inlet valve will open and fill the liquid in the storage tank. So when higher lower limits switch detect, the water, the connection between storage tank and feeder tank will close. So when the water reach the higher level sensor, the higher level sensor will open the higher level 2 sensor. So it's open the connection between the storage tank and feeder tank. So in that time, the liquid will flow into the storage tank and to the feeder tanks. So when the liquid rise and reach the higher level sensor 2, the higher limit switch will on, because the liquid detect by the higher level sensor 2. So after detection, the output valve will open. So when the lower levels 2 switch is detect, it will off and inlet valve will fill the storage tank again. So to open the output valve manually, we can switch on the manual switch to open the output valve. So that's all from me. Thank you.